So my name is Ken. I'm a senior software developer at PTAC Consulting Engineers. We are a engineering service provider, primarily servicing the precast industry with engineering services, shop detailing, ticket detailing, engineering, and all that sort of thing for precast concrete. So that's sort of where we come from. And what we've been doing over the past 4.5, give or take years, is working through an implementation of Revit that works for us. And what that's entailed is, sort of taking what's available in the Revit platform, manipulating that to some degree in terms of creating our own family type contents, and then building sort of a framework on top of that. And I'll show you why that framework, quote unquote, on top of that is important to facilitating a true sort of efficient workflow inside of Revit. So how many people came from AutoCAD days? Anybody from the drafting board days? That'd be me too. We were a little bit behind the curve. But it's all good times. Welcome, come on in. What we've been doing is working on an implementation of Revit. So Revit obviously is a great tool in the sense that a lot of architects are working with Revit now, and they're bringing in Revit. They're delivering Revit to the engineering staff in terms of attempting to communicate their design intent, so to speak. What we'd like to do, of course, is be able to help facilitate estimation workflows and shop drawing workflows and all of that sort of stuff. From the AutoCAD days, you realize that as you put together drawings, it's a kind of a tedious, hey, how you doing? But it's kind of a tedious process, right? You have to do the same things over and over and over and over again. So what happened with Revit? Well, Revit brought us a lot of functionality in terms of, allowing us to utilize a central database of information and extract information from that. So the views are live views, the schedules are live views. We'll talk about that in detail in a bit. In order to do that, you will find out that the Revit workflow for doing this type of shop drawing creation is also a somewhat tedious process. And so in order for us to really fully implement Revit as a platform for engineering and documentation, we wanted to increase the efficiency, and so we did a lot of programming on top of Revit within this framework that we've created to do that. So what we're going to do is we're going to talk about assemblies. So let me just give you a quick introduction. Ken, structural engineer in the past, software developer now, still recovering. Shannon Cooper is our lead draftsman, BIM manager, and he's support for the software stuff. So when anyone has questions or can't remember how to do something, they call Shannon, and he's pretty good at figuring out how to do that stuff. So next slide. I assume that since you guys all signed up for this class, on this thing? Wow, I've never had one of these. It's like power. I assume you all read that at some point, or at least glossed over it enough to realize that you wanted to come and sit in this course. So I'm not going to go through and read that. What we're going to do is I want you to, at the end of this class, I want you to understand how assemblies work in Revit, what their purpose is, how they're used to drive the entire shop drawing or ticketing workflow. I want you to learn how to use schedules and leverage some of the advanced features of schedules and how we can add information to the schedules, format schedules, group schedules, and total up information that we need for shop ticketing. And then briefly on view templates. View templates are an incredibly powerful tool inside of Revit. How many people are using Revit actively today on a day-to-day basis? 1, 2, 3, 4, 5, okay, 6, give or take, 7. So anybody using view templates right now? Seen them? Okay, pretty familiar. So we'll kind of gloss over that a little bit, but they're pretty powerful. They allow us to do a lot of enforce consistency across our drawings and that sort of thing. And we can utilize those and leverage them in our shop ticketing phase as well. I love this. So use view templates and then schedules again for the last part. So a lot of things in Revit are about schedules and utilizing that database, which is a 3D database. And it's not just the geometry, it's all of the data that's associated with those pieces and parts via parameters. And so you can add and remove parameters as you need. So if you want to track some additional piece of information about a part or a piece, whatever you want to call it, you can do that at any time. So you can add that data, you can fill that data out, you can add that to your schedules, and you can have all that information available to you for quantizing or material takeoffs or whatever you want. So we'll dive right in with assemblies. I'm going to talk a little bit about assemblies and what their strengths are and what their weaknesses are in their current workflow. And then we're going to do a little demo of how to create an assembly the manual way. So assemblies, they support fabrication documentation. And the way that they do this is by taking this small set of information. So sort of, you've got this entire Revit model, which is full of pieces and parts. And what you really want to do on a shop ticket is you want to focus on one particular piece, right? So an assembly is a way for us to say, these things are part of this assembly, and they are the thing I want to focus on. So an assembly in Revit is a container. It's a logical grouping of elements. It's not a thing. It's not an element. It doesn't consist of physical geometry. It's an idea that wraps up a set of elements. So we have elements that are members of an assembly or not members of an assembly. Okay? And that assembly membership defines the whether they're included or not. I don't know what I was thinking. So identify, classify, and document. You can combine any number of model elements. So in a precast piece, what do we have? We've got the concrete. That's great. We've got rebars. We've got welded wire fabric maybe. We might have embeds of some kind. We might have lifting components and hardware. All of those different things are different categories in Revit, but they can all be added to the assembly. So it also allows us to tag, schedule, and filter by these things. So we can treat them as a thing via this logical grouping, this container grouping that is assemblies. And each configuration of an assembly is a unique type. So in Revit, assemblies are quantified or classified by type. And Revit is very specific, we'll talk about that in a second, about what things match each other as an assembly. So facilitates this placement and logical grouping of elements. It also creates the foundation for shop drawings. So shop drawings are created in Revit from a or an assembly. So with no assembly, no shop drawings. You could create your shop drawings by creating a view that filters out everything from the view other than the things that you know are part of that assembly. You can create that view, you can put it on a ticket. You can manually do this process, but the assemblies allow us to group these things in a logical sort of way. In the Revit workflow or in the Revit mindset, when they designed assemblies, they also wanted it to be the thing that allows you to know that they're the same. So if we put the same components and pieces in, Revit can know that they're the same. There's a problem with that, though. It comes with some strings attached. So how are assembly types differentiated? Each unique assembly is a new assembly type, and we'll look at that in a minute. So they show up in the project browser at the bottom as a category of things that are organized in the project browser. So each assembly that you create gets its own place in the project browser, and all the things that are associated with it, shop drawings and schedules and all that stuff, will go together. But any edit that changes that will create necessarily a new type because it's no longer the same type that it was. It's geometrically different. And that's important, right? We don't want two things that are geometrically different to be called the same thing in our shop tickets. We don't want to wind up producing two of the same thing that aren't supposed to be the same, right? The benefit is, if there's another one in the whole project that is geometrically identical to this one, it will match it and give it the same name. And you can't change that. That's an ingrained Revit behavior. So it's good. And it also has some catches. So what constitutes matching? So assemblies can be associated with different categories. Everyone that's using Revit should know that we have different categories in Revit. Structural framing or specialty equipment or rebar or whatever that category happens to be. An assembly can be any one of the categories that it contains. So if an assembly contains a structural framing element and a specialty equipment element and a rebar element, it could be any one of those things in terms of its categorization. So the category has to be the same, the naming category has to be the same, and it has to include the same number of elements. So if one assembly has 3 plates, the matching assembly needs to have those same 3 plates. They have to be the same family and type. They have to have the same geometric configuration. So if the plate's 4x6, it needs to be 4x6 in both places. And it has to be geometrically identical. So all those plates have to be in the same location and have the same size. Okay? Any questions about that right now? Pretty straightforward stuff. there are some strings attached with the standard Revit assembly. The first one is changes don't propagate. So if you create an assembly, think you've done a good job, pop that in all the places that you think it goes, and then realize that you need to change something, change management is a problem because unlike groups, has anyone used groups? Yeah, groups are kind of fun, right? They propagate changes, you can edit them, and once you change the group, all the instances of that group change. Assemblies do not work that way. If you change an instance of an assembly, the changes do not propagate, you get a new type. So now, where you had DTA02, you have something else, because it's not the same as the other thing. So then you have to go and change all those other ones, or replace that all around the model, wherever it exists. Views that we create from an assembly, so these are what we're going to call the shop views or the ticket views. The views that we create from that assembly are associated to an instance of that assembly. So if we have 50 instances of the assembly around, whatever one we used to create the views, those views are attached or associated with that assembly. Why is that a problem? Who cares? It's a problem because if you change that assembly for some reason, have to add an element to it, want to change your rebar size, whatever it happens to be, that forces you to delete those views, or it forces you to stop in the middle of whatever you were doing, go find another instance of that thing, and what they call acquire views. I thought this was insane. So I used to work for Autodesk. I used to be a Revit QA quality assurance analyst. And so when we were developing this feature, I went, why are we doing this? This is crazy. So you'd have to find another instance of that assembly and acquire views, which would mean it would take those views from the one that you want to change and relocate them, reassociate them with a different instance of that assembly. I don't have an explanation for it. I don't know why. It just is. I didn't understand it when we were designing it either, so it's a little bit unique. Strings, right? These are challenges to utilizing assemblies for what we want to utilize them for. No tolerance. If that plate is 1/256th of an inch different than another instance's plate, they are not the same assembly. As far as Revit is concerned, it's really, really particular about this for some reason. But they wanted to guarantee geometric identicality. Just make up a word. So no tolerance is available. And we know that, as you're modeling things, it's very difficult to make sure that things are in the same exact place in all the different places that you put it. Even if you're really, really careful, you can still get these off, and we don't want to deal with that. We'd like to have a little bit of tolerance. Not all types of elements can be included in an assembly. So some of the more complicated elements like framing systems that grow and shrink with, as you change the size of it, it adds more members or subtracts them. Things like that, a little bit more complicated structural elements and annotations and some other things. So here's the non-exhaustive list of all of the things that cannot be included in an assembly. By and large, this is not a deal breaker for precast workflow. Like we don't care if the stairs can't be included in an assembly. Maybe we do, but they can't unless they are a particular type of stairs. So there's some give and take here. There's a little bit of gotcha in the sense that all of the things that we might want to include in an assembly, we can't necessarily include in an assembly. So that's a little bit of a gotcha, but for most of the work that we do in terms of our standard type of building that we typically produce, precast parking garages or precast buildings, concrete, double T's, standard sort of stuff, this doesn't hold us back at all. But it is a gotcha. So now we're going to flip over, and Shannon, my co-pilot, is going to take us through creating some assembly views, and I'll do my best to narrate. It's hard to keep up with him because he's so fast. I'm kind of kidding, but not really. So what we're going to do is we're going to start with the process of creating an assembly. And what we tend to do is we start with selecting the main thing that will kind of, in my opinion, anchor that assembly. So we're going to start with the structural framing element, the double T in this case. And you'll notice that once we get that up on the Create tab, there's a Assembly Creation button, or Create Assembly. And once you click that, you're going to get this dialog. So remember I was talking about this. This is where you can give it a name, and this is that naming category that we were talking about. Okay? So because I only picked one thing, I only got one naming category to choose from. Had I picked several things, and I could, I would have had an option to choose different categories. So our workflow is presuming that we've picked the structural framing element or the structural framing category as the naming category, and we're going to give that a name like DT whatever, 1000. And we'll hit OK. We also know that in order to, what I think of the assembly as, this is everything that's going into the casting bed. I gotta have, you know, one half of the wing-wangs, I've got to have, you know, flange connectors, what do you want to call them? I've got to have the embeds, I've got to have the plates, I've got to have the rebar, I've got to have the welded wire fabric, I've got to have all that stuff. So if you created an assembly before you've picked all of the various things, you can select that assembly, and then from right here you can choose Edit Assembly and go ahead and add any of the things that you need additionally for that. So what we do at PTAC to facilitate our modeling process is that we add these, so these flange connectors you'll notice have two pieces. So he's tabbing in to get the nested component. So we create our connection families as one large thing. So as you get over to the, you know, the T-girder, or this is the wall panel connector, you'll see that this is one family. This is one whole family here, and it's got nested families inside of it. So we'll tab in and grab the part that's embedded in the piece that we want to include in the assembly. That just allows us to be more efficient with our creating connections. So instead of putting an embed plate in the double T, putting an embed plate in the wall, trying to locate those in the same position, the same location, and then add the stitch plate in between, we put them all in as one thing with nested families so that they can be quantified later. So that's a little bit of an efficiency enhancement on one side, but if you're going to do a manual process of creating these assemblies, you will have to, you know, tab in and get the piece that you really want. So as you can see, this is a quite manual process. You can speed this up somewhat with some crossing selections and some box selections. You can be a little bit smarter than he is about, but I really wanted to see what it's like. This is a pretty simple model, right? Our models are much more complicated than this in general. So being able to tab in and see these things, scrunch your view down so that you can see what you're looking at and not get confused with other elements, because it can be easy to pick the wrong elements to pop in there. So once he's got that mostly done, we can finish that, and now you'll see that as he hovers over that, you'll see that all of these pieces and parts are now considered part of that assembly. And the way Revit selection works is once you've made it an assembly, the top level thing that it wants to select when you hover over it is the logical grouping of things that is the assembly. And assemblies have a few properties like the assembly mark number and assembly control number. So it's got some data associated with it itself, as well as the pieces that are within that logical grouping. If you wanted to get back down to your double T, as you hover over it, you'll have to tab once before you click. Revit people know this intrinsically. My hand is on the tab key the whole time I'm working. But that's the way that you get down into the individual pieces of this. So now that we have an assembly and we have all of the things that go or are grouped together, now we're in a position where we're ready to start creating shop drawings from this. Okay? And one of the key components of the shop drawing creation is Revit automates the process of shop drawing creation, but it wants to know how you want those drawings oriented. So they've provided a tool that's called the Assembly Origin tool. It's a set of axes that you orient. And what that does is it allows you to set up the box. So you imagine a conceptual box around this thing that you want to detail or document. However we orient that assembly is going to orient that box. So we could orient it skewed, orthogonal to this member. Our standard, of course, and I assume most everyone's standard, is to orient it orthogonally. So as he selects this assembly, and you'll see that up here, when we go to Edit Assembly, there's this little thing. This is what is called the Assembly Origin tool, let's call it. I don't even know what it's called. Assembly Origin is what it really is. And when you select it, you get 3 axes. It's the right-hand rule. We have the red axis that represents X, green, which represents, he's done it now. Green, which represents Y, and blue, which represents Z. So that's going to orient this whole box around the element. So what we like to do is have our standard top view come out looking on a double T like a top view. So what we want to do is orient the X-axis along that top long direction of the element, so that when the shop drawing is automatically created for us, it's already in that orientation. We could adjust that if we left it alone. We could just change every one, but it's nice to have it in oriented in the way that we like, so to speak. So once you finish that, That sort of reoriented that box. And now up on the contextual tab again is create views. So that's creating new shop drawing views and associating them with that instance of the assembly. Okay? So this dialog, we have a scale selection. Doesn't give you any help really. You have to sort of guess. We have a lot of intuition about what to use, right? You know about how long the member is, you know about what scale you typically use. But you can adjust that or use a custom scale if you need to. So from that drop-down list, you could also use a custom scale and type in your own scale factor if you needed to. Kind of a crazy member that wouldn't really fit nicely on a sheet or something like that. So you can choose any set of views. So this is a 3D ortho view, plan views, sections. So we have 2 sections through the thing. This is a fixed list. There's nothing else we can do about it. It is what Autodesk delivers for us to utilize. But so there's a cross section and a long section, so to speak. Top views, side views, front views, left views, back views. And there's also some parts lists. So we got the automated parts list and material takeoff. We're going to include those. And we're going to show you how to modify those to get additional information included in them if you should want it. And we can also create a sheet at the same time and choose from available sheets or title blocks, I shouldn't say that. Create a sheet with a title block specified. So once we've picked out, so we got a top and a right and a front and a parts list and material takeoff, that's kind of the stuff that we want for a double T template. I want to keep an eye on the time. I have a terrible tendency to run over because I just love talking about this stuff. So when it hits OK, Revit's going to automatically go and create all those drawings for us. So here's our top view. Remember I said that assemblies wind up in their own category down here in the project browser? So there's my DT1000 I created. And all of those views that I asked it to create are right here, including the sheet, parts list, material takeoff, and my views that I want to include on the sheet. So in order to start building, you'll notice that my sheet is actually empty. So it didn't really help me that much other than the fact that it created those views. The next step in the process is to start taking these views, just like other Revit views, any of your general assembly views or erection drawings, that sort of thing, and start placing them around the sheet in the way that you want them, okay? Once you've got those placed, one of the things that we need to deal with is most of the time we wouldn't want to show this in this orientation. We'd want to rotate it into, you know, sort of look like it's the side view of the thing. One of the ways that we can do that is by the rotation on sheet parameter right over here. So if you select that view and select that view and there you go. No, you want to not select the view, but the view port, so to speak. Know what I mean? All right. I tried to get him to talk. He wouldn't talk. He's like, no one will make me talk. So anyway, you can use none counterclockwise or clockwise as a rotation. So that's great, but here's the catch. If you do it that way and you put the title on, it rotates the title with it, which is a little bit odd. Maybe or maybe not the way you want it to be done. There is another option. So another way around that is to select that and turn on the crop region. You can actually rotate the crop region of a view. You can do this with any Revit view. It gets a little wacky. But you can do that, change the rotation. And notice that he put in a clockwise 90-degree rotation and actually rotate it the other way. I still have not figured out why it does that, but it does. So just be aware of that little thing. So you can do that, and then if you turn the titles on again, you'll see that they're still on the bottom where you would expect them to be. So that's a little bit of a trick for dealing with rotating views on the sheet and keeping the titles, if you like titles, in the right place. So you notice the other thing, this isn't a very helpful view, right? This isn't like the kind of information that we really want to show in a shop ticket. We want to show the rebar in there, we want to show the embeds, we want to be able to dimension those things as well. So what we're going to use to do that is the view templates. I already lost one. We're going to use view templates. Stay tuned. So if you select that view and go to, let's show how we would do this normally. So we could select that view and go to visibility graphics. This is where you can override any of the behaviors of that view. So we could like maybe take structural framing, we'll override that structural framing, we'll give it a, let's give it like a 12. Be bold and maybe change the color to blue or something, it doesn't really matter. Hit OK and OK and OK. So you can see that we've changed the effect of that view, the way that it's visualized currently by overriding those parameters. Now we could take that information and we could encode that into a view template. So we can take that view, we can save a view template of it, or we could set up a custom view template and just configure those. So the view template tool is part of this view. It's down here. It's currently set to none. But if we click that right now, we'll get taken to the view templates, whatever you want to call it, dialog, where we can choose from our pre-configured view templates, or we can create a new one. So we can duplicate one, change the parameters. These, we can choose what things we want to include in that view template. So for shop drawing views, we want to be able to configure the scale independently. So we leave that unchecked so that it doesn't override the scale for our views. But if you did stuff where your scales were always all the same, include it. It'll just get applied automatically. It's no big deal. But ours, we leave it unchecked. And here's where Visibility Graphics overrides model. So click that button for me. This is where you can override all of those settings. So you can choose what all of your view settings are for that view and apply them via a view template. Once that's applied, it controls the view. You can't change it, which is a good thing. So we don't want the views that we wind up putting on sheets to be changed ad hoc or accidentally. So this is our standard double T top view template, so to speak. Sets up some nice line weights for us and shows us the stuff that we want to see. The next step in this process, of course, is to go and dimension all those things, right? So we're going to pop the dimensions on, we're going to string them out, we're going to put the names of the plates that we're dimensioning or the bars or whatever it happens to be. And then we can go ahead and apply those other view templates to the rest of those views. And this is the setting up of view sheets or views on that ticket sheet. So all of those steps have to be repeated for every single assembly that you're going to document. Okay? It's a little bit intense. Next thing we want to do is talk about schedules. So schedules in Revit are just another view. Question? Which one? Dimensioning? Yes, manual process as well. Revit dimensions are pretty good, and the fact, one of the things I think is great about Revit dimensions is if something changes, the dimension is smart and it stays attached to the references. So if the references change, the dimension string changes. So there is that advantage of Revit in the sense of even if you're doing that work, it's not for naught necessarily. Okay? We're not going to go through that process because that's literally just a manual process at this point, and it's something that all of our ticket cleaners know how to do. Next step in this process, let's get into the schedules. Let's pop those schedules on here, and we'll start to talk about schedules. So the out of the box, what Revit creates for you automatically in terms of the schedule, it's not quite well formatted. Like this isn't necessarily something you'd want to put right onto a shop ticket. It's enumerating every single instance of the whole of everything in the piece. It's probably, if you zoom in, I think it's including the structural framing as a piece that is part of the assembly, and that's kind of weird because obviously the precast is the whole thing. So what we're going to do now is we're going to edit this schedule. I'm going to show you some of the inner workings of schedules, so to speak, or new things, hopefully, that you don't know about schedules or we're always curious about. This is the edit schedule view. And when you go over here to the side, you can access the information about that schedule. So what he's done is clicked filter first, but these things just map to the things up here. I don't know why there's not just one button that says edit, because it all is up here in the top. So what we're going to do is we're going to set the category does not equal structural framing. I don't need to see the structural framing element in my piece, but I'll quantify that later in my material takeoff. So I'm just going to use this filter to, apply a little dumb filter to take that out of the view. So, like I said, schedules are just another view of the data in the model. So if I want to change what's shown, I need to filter it in some way. Okay? So other things that we want to put on here. What else do we do with this schedule? Sorting grouping. So I'm going to sort and group on family type. And instead of itemize every instance, I'm going to uncheck that and hit OK so you can see what the difference is. So now I've just got all of the things that I have plus their counts, which is pretty helpful. That's a much nicer schedule.
Could you redefine that like the view template?
No. You're jumping the gun. But yes, now that you spilled the beans, it's a manual process. And so everything that we're about to do, you would have to do to every single schedule on every single ticket that you produce. This is a pain. So let's talk about some other things that you can do with schedules. So we don't need the specialty equipment category. So we can go to formatting, and for category, we can just make that a hidden field. We don't need that in there, so we can leave that out. Now we've got some more information that we want. Let's pretend, I'm sure that nobody does this, but let's pretend for the sake of argument that you like to include a cost with all of your pieces and parts. So I'm going to go down and grab the cost field out of my parameter list. So this is the list of all of the parameters available to you to schedule. You don't have to choose the parameters that Revit gives you. You can add or remove any parameters to that schedule that you want. It's just going to show you that data. So we're going to put in a cost, but I don't want to put in the cost that's my cost. I want to put in a cost plus a markup. Okay? So what I'm going to do is add what we call a calculated value. So we're adding another column to our schedule to display information that we want to display. And we can do that with a formula based on the cost, and I'll just make it 10% more. A little extra money in my pocket, right? Whatever, just kidding. And we go to formatting, and we don't want to see the cost field, we want to see the estimated cost. And for estimated cost, we want to calculate totals, okay? So if we do those things and hit OK, now we'll get totaled up the total cost for each of those things. I can see what the total cost for that ticket is going to be. Okay. We could also do totals for the entire thing. So if we go back to sorting and grouping, we can, where is it? Yeah, grand totals, whatever, something. Totals only, hit OK, and then I can get a total number for the whole thing. So you can imagine utilizing this schedule for all of the pieces that you've modeled, adding some cost information. You don't have to do this just for a ticket. These schedules can be created for any view, any category. So anything that you want to group and calculate fields for and total things up, if you put them together and put it in as a template in your, or add it to your Revit template, then it's there and available for you. So we've got a schedule that's a product schedule, and as we're adding double T's, it's just automatically filling that up for us. Anytime we want to look at it, we can look at it, see what our estimated cost is, or our estimated total concrete is, or whatever those things happen to be. We're in a good position to be able to immediately extract information once we've modeled it. So this is what I'm going to call a Revit template as opposed to a view template. So I don't know what he's doing, just farting around with stuff. So we can take that and move it into position. He's got the columns sort of nicely lined up with stuff maybe, or he's going to have to line those columns up and adjust them in some way. Maybe move it into position, wherever that is. So kind of a manual process. The next thing we want to look at is we like to put a total ticket weight on our tickets. So how would we do that? We could start with the material takeoff tool. So we've got this material takeoff that's been automatically generated for us. It's got the volumes of various materials. You notice that all of my rebar is 0.0000 cubic yards. Well, of course, it's 0.00 cubic yards because it's a really small amount of rebar relative to the cubic yard. So we could change the way that this is displayed in terms of precision. So we could go to formatting and change for material volume. We can change the field format. Instead of using the project settings, we could put in a custom format and string that out a little bit. We could change that to feet, cubic feet or cubic yards, whatever you want to do. So we could change it if you want and hit OK. And now you see that we've got some amount of volume registering for that visually, okay? So you have control at the field level how you want to display that unit information. You don't have to use the overall project settings for your unit information. The next thing that we want to do is add in, so we need to add in our unit weight field. So we need to know how much this stuff weighs per unit since we have the units now. So we've got a weight per unit parameter. That's a parameter that we created and added to Revit, and we associated it with all the elements in the project. So any element that I want to have a unit weight for, I can pop that parameter, and we've filled it out ahead of time so that it's got the right things in it. Yeah, not control mark, buddy. No, we don't need that. It's good. So weight per unit, we're going to add a calculated value. And the calculated value is going to be weight, and then we're going to have a formula for calculating that weight. So we're just going to use the volume of material. We're going to multiply that by our weight per unit that we've already encoded in there. And, see if you can do it. I had him put it on another sheet, so in case he needed, you could paste it in. So anyway, we've taken the thing, we've done a little bit of conversion, and we've, because our weight per unit is in cubic feet, whereas our volume's coming in cubic yards. So we just did a little calculation there. We hit OK, and then hit OK again before we do any more formatting. So you see that I've got my weight per unit, so I've got 490 in there for steel and 150 in there for concrete. So we're calculating a total weight for that piece and a total weight for the rebar. So we could total up those, gives us some more valuable information. If I want to put the weight on the ticket, unfortunately, it's sort of a breaking process. So this Revit's great. It keeps all the things together. It keeps all the data consistent. But if I want to put that information onto my title block, I've got to copy it sort of manually into there and put it in, okay? Breaks the Revit workflow a little bit because if I change this piece, and this will change automatically, but this will not. So we've done some things to help automate that process to some degree, but just note that copying that information, instead of listing it here, listing it in the title block in particular, just is a breaking, it sort of puts a gap, a cavern in between those pieces of data. They're no longer linked together, okay? So that's a little bit about how we can utilize schedules, utilizing hidden fields, calculated fields to create new values or fields or columns of data that we want to show based potentially on calculations that we've done on other fields in that schedule. Hiding fields, grouping and totaling, and what else do we cover? Anything? Should ask you. Pop quiz. Okay, so any questions about schedules right now? Anyone bored to tears? All right, that's good. What we're going to move to next is what? Creating an assembly. Did we talk about, yeah, we talked about that. We've got the sheet, got the schedules on the sheet. Okay. All right, we're 40 minutes in-ish. Okay. See, I do tend to go over. What you've seen is the out-of-the-box, give or take, Revit workflow. These are the set of tools that Revit gives you to create assemblies and to create shop tickets and all that stuff. So remember, in order to create shop tickets, we have to select every piece that goes into the assembly. We have to then create the assembly views, manually place them onto the sheet, manually reconfigure the schedules. I mean, we're probably not going to put calculated values into every single shop ticket schedule that we do, but if you wanted to, you would have to manually do that for every single one of them. You would also have to manually adjust the column widths, because the column widths come in the same way every single time. So you have to manually adjust those for every single ticket. Pretty tedious process. So we've just spent 40 minutes working on this, maybe 10 minutes talking. The rest of it is just manual processes of adjusting these things and getting them set up. So the question that we had at PTAG is, this is great. We want to be able to use Revit. We want to be able to take information in from the architect. How do we get efficient with this? That was the question that we asked ourselves. So tools that we have available, well, nowadays we have Dynamo, but back in the day we didn't have Dynamo. There was no Dynamo. So we started developing tools on top of the Revit API to help us facilitate these workflows. So that's why I'm a software developer instead of a structural engineer. So most of my job is to help make our team as productive as possible, and then we wanted to share that with the rest of the community. One of my passions, in particular, having come from a structural engineering background, is helping our entire industry utilize and take advantage of these technologies that we now have via Revit and Autodesk and all the integration that they have. So that's sort of a little bit more insight on my background. Obviously, grabbing and selecting all these little individual things is kind of a pain in the butt. So one of the first tools that we designed or coded was, let's take the fact that these things are embedded in that concrete piece and leverage that fact to identify the things that should be included in the assembly. And so instead of going and picking, we have a tool that's called Assembly Creation. You just click that tool by selecting the structural framing element, and that's how fast it is. Just like that. So no more clicking and picking and tabbing and all that business. We just utilize the fact that all of those things create a geometric interference with that structural framing element. So in modern day, you could utilize Dynamo for the same thing. So you could leverage a Dynamo script to identify those interfering pieces and collect them up into part of that assembly. So we've just automated that process to make it really quick. Click the piece, click the tool, done. The next thing that we want to do is orient the assembly origin. We've seen how to do that manually by creating the thing, editing the thing, orienting the little axes around. We created a tool to make it easy because we've got some people that don't know how to do it. And so we created a tool for it. So we click that tool and we isolate the assembly. This makes it a lot easier to pick the things that we need to pick. So we don't have all that extra congestion of the other model pieces around. So we just click the top is cast face, the mark end, and the right end. And that just helps us orient that assembly. You know, it's pretty straightforward. And we get a little graphic. That was my idea, to put the little graphic on there so you could see what it was. And if you highlight that and open it and select the assembly origin, you'll see that the assembly origin has been moved to that same place. Is that a real efficiency enhancer? No. If you know how to manipulate this assembly origin, you can be pretty quick with it. But if you can do it really quick with graphical editing, it's kind of easy and fun. And you get a cool little graphic. So once we've done that, we've got to create the assembly view. So what we're going to do now is I'm going to have Shannon go through and create a shop ticket. We're going to lay it out. I'm just going to let him kind of turn and burn on that because he's really good at it. One of the few things. Anyway, and I'm going to let him do that. He's going to apply the view templates. And then when he's done with that, he's going to add some, I think we have a note that we'll place just to sort of illustrate this fact. Any legend views that we have, so we have sort of standard details or standard notes or standard anything we want to include with this ticket, we're going to lay that out on top of that ticket as well, because what we're going to do next is we're going to create a template from that. Once we've made that layout, why can't we just take that information that we have in terms of the number of views, the types of views, the orientations of those views, why can't we just remember that and then use that to make the next one? So that was the thought behind this whole thing. So I'm just going to let him add that. He's going to add a note, created the templates, applied the view templates already. One thing that we then did, this problem of the schedules, you'll see that, highlight those things again. The problem with this schedule thing is that all the adjusting of the widths of the columns and adding fields and calculated fields and adjusting the formatting, we thought that was a colossal pain in the butt. However, there's no way currently to create a templating thing for that view, for that schedule view, to have it automatically placed in the way that we want it. So we had to sort of rewind a little bit. Was anybody here yesterday for the Manufacturers Fabricators Forum? One. Did you see Marius's talk? Yeah, it was kind of crazy. So they did this this whole thing, and his whole point is kind of like there's a mindset to sort of venturing into this 3D world, which is there is a way to do it if you have the will to do it. And so this was kind of a big stumbling block for us because it's a colossal amount of time wasted if you don't do something about this. So what we chose to do is create some schedule templates, quote unquote. And what I mean by that is just something we call a template. It's just a schedule. It has information. And then we're going to do some stuff behind the scenes. And remember I was talking about this framework that we kind of put around stuff? One of those components of that framework is what we call a construction product host. And we automatically write it. So when we created this assembly, could you pop into that assembly and yeah, and look at the, yeah, so this thing, wing wang. Is there a real name for that? I did structural steel. I didn't do precast when I was a structural engineer. So anyway, I call it wing wang. So in that wing wang, we've got a construction product host. You'll see that's DTO4, so that's its parent. So in that same process that we were locating things within that precast member, we also took time to pop that DT4 in there. We can leverage that in these schedules, okay? So what this next tool does is we go there, start to duplicate schedule. So it's going to go and grab the schedules that are appropriate for this, and he's just going to be able to automatically place them. So see, this is the DTO4 parts list. It's just a copy of that schedule, all right? And it's already formatted the way we want it. It's got the columns the right width and everything. And if you go and go into the schedule and go to the filter, you'll notice that right here we have this construction product host set to DTO4. That's the magic. Magic. There's no magic really. So we've just done this behind the scenes. We've automatically set the construction product host, then the tool duplicates the schedule, and it adds this DTO4 filter to that schedule. That's how I get it looking and containing only the information that's part of that assembly. So it's just a little bit of sleight of hand, right? Again, in a modern day, it's nothing that you couldn't necessarily do with a fancy Dynamo script if you had the time to write it. But that makes us a lot more effective and efficient. So being able to click that tool and duplicate the schedules and set that filter automatically makes it so much easier, makes it a lot faster. So that's one of the reasons why we developed that tool. Now I have a model ticket. So I've got some extra information, views that I need, rotations that I need, and the schedule that I need. The next thing that we did was create something where we can just record that. So let's record it by going to the admin tab, and we'll create a template out of that. Create a template, we give it a name, something. We pick an alignment for the bill of materials. We're going to align that to the bottom because we want it located from the bottom to the top, and we're just going to stack those. So if we had multiple bill of materials, maybe we had welded wired fabric in there, or C-grid schedule in there, or whatever it happens to be, we could add those schedules in as well automatically. So he's going to create that template. It's just going to save them into a template file. Pretty straightforward stuff. The magic is what happens now. Because now that we're in a situation where we've sort of pre-configured everything in terms of utilizing this ticket template saving, having our tools that do the all of the whatchamacallit, schedule manipulation, how am I doing on time? And that sort of thing. All we really need to do is click the thing, create the assembly, set the assembly origin, and then all we need to do is select that and go to ticket tools and ticket populator. And so that's the final solution on that. So that's the template we just created. You can adjust the scale if you need to, but that comes from the template originally. And click populate. So it's just a tool that we made that makes us really efficient. Whole lot faster, right? And the crowd went wild. Did it do it? Oh, yeah. Oh, yeah, we did a little rehearsal earlier, and we were pretty excited. So anyway, you can see how efficient this can be on top of Revit, but in contrast to how, what the out-of-the-box tools are. So this is the way with a lot of Autodesk tool sets. So Autodesk will deliver some new functionality. They'll usually get about halfway through it, and then they'll get sort of distracted by some bright, shiny object. So you noticed it, right? Eventually, they'll get back around to it, potentially. And I think a lot of times they see the kinds of things that we do to make ourselves more efficient. We're in pretty close contact with them. You were here for the manufacturers forum, and you're already using Edge, yeah, okay. So we got people already in the hook, line, and sinker. But you can obviously see that if you want to implement Revit for a full shop drawing workflow, it's a pretty tedious task out of the box. Efficiency add-ons can help that. There are several different add-ons available. So AGA CAD is doing stuff around this. Edge for Revit is our sub-company, so to speak, it's our software development arm, I guess, if you will, because we found that while these things make us more efficient, I don't think we have a mission statement or anything, but I feel like, and my sense is that we want to share these tools with the world. And so if we can increase the efficiency and increase the ability to utilize and leverage Revit, I think we all see that it can be a much broader, much more applicable platform, especially for the precast industry. We haven't seen a lot of adoption until we started creating some of these tools on top of Revit, and people started to get the sense that Revit can be used for precast with a little bit of help from some automation. So these are just some examples of our shop tickets. You see this is the stacked bill of materials. Here's a little additional schedule, a template that gets created with it. There's some standard details or mark numbers. All the dimensions still are manual. That's something we're working on. How do we take that to the next step so we can automate the dimensioning on these things? And then it'll just make it a breeze, make it almost painless to create an assembly. So you can take advantage of all those sort of tools. So that's my story for today. That's what I wanted to communicate. Does anyone have any questions at this point?
What will happen if that you just change a little bit, then it will turn into a new assembly?
It will turn into assembly. This is,
And then you change a little bit from the
yeah, this is a key.
keep track of the having
Yes,
going through all the assemblies.
because we short-circuited it. And the way we did that was by only having one assembly as the recipe. So in our workflow, assemblies are, our whole workflow hinges on having one assembly that represents all of the places it's going to be. So what we do is we use that structural framing element to show where that's going to go. We associate them by having the same control mark. So it's all keyed on that control mark. We pick one of those to create an assembly from, and that does two things for us. The first thing is I only put rebar, lifting, and handling components in that assembly. That's my recipe that describes what we're actually going to pour in the bed, okay? In doing that, all the rest are just placeholders, and then I've got a bunch of magic behind the scenes that tallies up my quantities for me. So let's go back to the shop ticket, because I'll address your other question too in a second, and how that happens. So you notice that this title block is also automatically filled out with all that information. There's the yards and the weight, and I had to manually copy that before. Just automated all that same thing. So we've also got, oh, we only have one. Sorry, I was like, why is there only one?
I can make this the same thing if you would like to show.
Oh yeah, you should be able to do that. Yeah. No, you don't need to recreate it. Nope. But you do have to rerun the title block populator. Yes. So it's always like you go off script and then it's bound to go wrong. But hey, it all worked. So behind the scenes, we figure out that there's another one, structural framing element, that has the same control mark, but we only have one recipe. That's our secret sauce, so to speak. So we're not modeling rebar at every single place that it exists. What we're doing behind the scenes, there's another trick behind the scenes that we're doing, is the following. Can you go select one of those rebarbs? In the assembly. Yeah. And nope, this isn't going to work. Anyway, there's a little bit of manual. There's still like, everything's not completely automated yet. There's still like some manual steps in the whole process. So anyway, you notice that there's a count multiplier. So basically what that says is I know that I'm only modeling my rebar in one place, but I know that it needs to exist in all the places that I have these placeholder elements. So the count multiplier is the thing that I use behind the scenes to stick that information in. So when I run the what we call the BOM product hosting updater, it fills out that quantity count multiplier automatically for me, and that allows me to drive my schedules with actual quantities of the rebar that I need. Okay, so precisely, could have worked. I've done enough of these to, I don't know. Has anyone ever given a presentation where you like went off script and like nothing worked? That's my life. But luckily it's all working. So count multiplier 3, so I know that I've got 3 of those same assemblies. I know that I need 3 of those same rebars. So it does, one of the things it does for it allows us to keep the model from getting too heavy. Okay? Did anyone see, did you see Project Brand yesterday from Autodesk? Their walls and thing dividers? Yeah. So Autodesk is putting together some automation tools around what they're calling European residential construction, which is walls and flat slabs. There's no corbels, there's no columns, there's no anything like that. But they've automated a lot of those tools they can take a Revit wall and break it up automatically and create assemblies from parts. So parts is something that we haven't talked about because it's not part of our workflow at PTAC, but it is a viable, or it's a potential workflow for also creating shop drawings. So I guess you could look at IDAT. I guess they don't even have any information anymore. They probably have some information. There were some rebar or some precast fabrication tools that they bought from a company called IDAT in Germany. And IDAT's whole thing was, let's take a Revit wall, which is a totally different element, and break it up into parts and then use those parts as our assembly creation. So we're basing our assemblies on loadable families, whereas Autodesk is basing their assemblies on parts. So parts is a whole other story. We'll probably talk for another hour about parts in general, but also powerful functionality for fabrication documentation. So it allows us to keep our model light, and it allows us to do this sort of, I don't have to worry about, thank you, I don't have to worry about the assembly changing because I only have one of them. One of them. Okay? So it's a little bit of like, how do we achieve what we want to achieve and work around some of these strings that come attached with assemblies, okay? We also have tools like, we've just started developing mark verification. So what we've wanted to do is implement a tolerance in terms of identifying things that are the same. So we've recently implemented that behind the scenes. We hope to be delivering that soon. Things like that will help us speed up our workflow as well by identifying things that are identical or identical enough for us. Other questions about the shop ticketing workflow, the Revit workflow, assemblies, schedules? Want to play Stump the Chump? Cool with that? All right. You are free to go. Thank you very much.